In this video, we're going to learn how to write a molecular formula using both the empirical formula and the molecular mass. So here's our learning target. Now, I want you to remember that empirical formulas are the formulas with the simplest ratio. We've taken that ratio and we have reduced it to its simplest form. So in an earlier video, we looked at this slide where we saw that if we have C6H6, that reduces to CH, 1-to-1 ratio. C6H12O6 reduces to CH2. Pb2O4 reduces to PbO2. Many covalent compounds are going to have the same empirical formula. For example, glucose and formaldehyde both have an empirical formula of CH2O. Benzene and cyclobutadiene, C6H6C4H4, the empirical formula is CH for both of those. So how can we tell the difference between these formulas? We use the mass. The ratios are going to be the same, but the mass is going to be a multiple of that empirical formula. So for example, glucose and formaldehyde both have CH2O as their empirical formula. So the mass is 30. Okay, that's a 1-to-1 ratio for formaldehyde. 180 is 6 times as big as 30, so we have C6H12O6. For benzene cyclobutadiene, the empirical formula is CH, so that molar mass is 13. 52 is 4 times 13. 78 is 6 times 13, and that's where we get our multiples of our empirical formulas. So to find molecular formula, we're going to need 3 things. We're going to need the empirical formula, and that will either be given to us or we can calculate it using what we've learned in an earlier learning target. The mass of the empirical formula, which we're going to calculate from the periodic table, that's just molar mass. Okay, so this is just molar mass. And we're going to do the mass of the molecular formula, which will be given in the problem. We can't know it any other way. Okay, so that will be given in the problem. So to find the molecular formula, we're going to need to find out what the multiple is. So we take the mass of the molecular formula and we divide it by the mass of the empirical formula. And this should give you a whole number multiple. So what do we do with that multiple? Well, we're going to multiply it by the subscript. So for example, let's use benzene. We know that the empirical formula is CH. CH has a molar mass of 13. Carbon is 12, hydrogen is 1. This came from your periodic table. Okay, so that came from your periodic table. The mass of the molecular formula would be given in the problem. So we take our 78, we divide it by 13, and we get 6. So the molecular formula for benzene is 6 times its empirical formula. So we take that 6 and we multiply our subscripts and we get C6H6 as the molecular formula for benzene. In this problem, what is the molecular formula of dichloroacetic acid? If its empirical formula is CHOCl and its molar mass is 129 grams per mole. So think about those 3 things that you need. You need your empirical formula, which they gave you in the problem. This is a good start for chocolate too, by the way. They gave that to us in the problem, so we need to find the mass of this guy. So we're just going to take and do carbon is 12, hydrogen's 1, oxygen 16, chlorine is 35.45. So that's where we get 64 from. Okay, so we're doing this little baby here. And since these are all 1s, they're all going to add up. Now this is rounded a little differently, but you get the picture. The mass of the molecular formula was given to us in the problem. Okay, so right here. So we're going to take that molecular formula mass and divide it by our empirical formula mass. So you're going to be doing the bigger number divided by the smaller number here because you're going to get a whole number ratio. So our molecular formula is 2 times the mass of our empirical formula. So we multiply all of our subscripts and we get C2H2O2Cl2. Now what happens if they don't give us the empirical formula? Well, we can calculate that with no problem. We have done this before. So an unknown hydrocarbon is found to contain 85.7% carbon and 14.3% hydrogen. It has an atomic mass, which is the same as molar mass, of 84 grams per mole. What is its molecular formula? All right, so I need the empirical formula, I need the mass of that empirical formula, and I need the mass of my molecular formula. All right, so they give me that one. I have to find these other two using this information. So we go back to our empirical formula. Remember that we assume a 100 gram sample, so we can change our percents to grams. And with grams, we need to convert to moles. So 85.7 grams of carbon, we're going to convert to moles. And that is going to give me 7.142 moles for carbon. We're going to do the same for hydrogen, so 14.3 grams of hydrogen. 1 gram per mole for hydrogen, so that's 14.3 moles. All right, so now we divide by the smallest, which is our 7.142 here. So that's going to give me 1 mole of carbon and 2 moles of hydrogen. So my empirical formula, oh, you know what, let me do this. There it is. So my empirical formula is CH2. So I need the mass of CH2. All right, so 1 carbon is 12, hydrogen is 1. So 12 plus 2 gives me a molar mass of 14 grams per mole. So 84 divided by 14 is going to give me 6. So I multiply 6 by my empirical formula of CH2. So my molecular formula is C6H12.